Hello, welcome back to AIT 1001. My name is Matt Luckett, and for this demonstration we're going to look at how to use a digital multimeter. The three primary measurements that you'll make with a digital multimeter is resistance, amperage, and voltage. And I've got a simple circuit set up here. I've got a 12 volt DC supply. I've got a conductor running to my selector switch. From my selector switch I'm going to my lamp, and then from my lamp back to my common on my power supply. So what we're going to do is we're going to use a multimeter to measure the voltage, resistance, and current of this circuit. So I'm going to turn my power supply on. So the first thing I want to do is measure my voltage. And here I have my voltage source. So the first thing I need to do is set my meter up to read voltage. So I have my black lead in the common port, and I have my red lead in the voltage and ohms port. And if you look real close, you can see on where these leads are plugged in, they're actually labeled as to what they're going to measure. So my common port, my black lead will always stay there, and my red lead I may have to move depending on what I'm measuring. But this port here is good for taking voltage and resistance readings. So my lead is plugged into the right port. I'm going to turn my selector dial around here to measure DC voltage. As for this section is DC voltage indicated by the DC symbol, and then this section down here is for AC voltage designated by the V with the sine wave. So I know my circuit is DC voltage, so the first thing I'm going to do is measure my source voltage. So I go up here and touch the black lead to my common, the red lead to my positive. I'm showing roughly 12.5 volts here. It's kind of moving around a little bit. That's okay. We just kind of take the average of the read. But 12.5 or 12.2 volts is what the power supply is outputting. So the next component in my circuit is the selector switch. So if I read across my selector switch, this switch actually turns the circuit off and on, which will illuminate my lamp. With the switch off, that means this circuit is open at this point. So if I measure across this open switch with my digital multimeter, it's going to show, I should read my system voltage across this open switch because it's dropping all of the voltage for the circuit. So I can go on one side of the switch and the other side of the switch and see that I do indeed have my complete total system voltage. That is because the circuit is broken, or the circuit is open at this point. Now if I close my switch and now read across my switch again, I should read 0 volts, or next to 0 volts, and I do. And what's happening here, when you use a digital multimeter, especially for testing voltage, the meter is not going to tell you whether or not there's voltage present, because obviously we have voltage present. My lamp is illuminated, but my meter is reading 0 volts. And the reason that is, the meter is actually displaying across the display what the difference in potential between where this lead is placed and where this lead is placed. And with the switch open, there's actually a difference in potential. I have 12 volts on this side of the switch and 0 volts over here. So when I test it with my meter, it shows that difference in potential between those 2 points. So when I close the switch, and now I have essentially 0 ohms from here to here, there is no difference in potential between this point and this point, and that is what my meter is showing me, is that I have 0 potential. But there's voltage present, we know that. So that's one of the important things you need to understand about using a digital multimeter. Is it's displaying values, but you need to understand what those values are telling you. So now that this switch is closed, now I'm going to be dropping all of my voltage across my lamp. So if I read across my lamp here, you'll see now that I'm reading 12 volts across my lamp, or the total system voltage, because that is the only thing in my circuit. And you'll find out more later as you progress through this class and get into series and parallel circuits and combination circuits of how all this comes into play when you start adding multiple loads. But right now with a single load, all the voltage for the system will be dropped across that one load. So like I said, we have 12 volts. And so that's essentially how you measure voltage. You don't have to break the circuit anywhere. You just touch your leads to the different points to determine the voltage drop, or the difference of potential between those 2 points. Now the second measurement we're going to make is resistance. We're going to take we're going to turn the circuit off, because we have to make you cannot make a resistance measurement with power on the circuit, so we have to remove power from the circuit, and we leave our red lead here plugged into the same port, or the same jack on the multimeter, because this jack is good. You use this for voltage and resistance. So I'm going to turn my dial around here to the resistance portion of the meter to make a resistance measurement. Now, there's one thing you need to understand when you make a resistance measurement is I've got a complete circuit here. So if I wanted to measure the resistance across this lamp, if I didn't disconnect anything and just touch the lamp, I'm not only reading the resistance across the lamp, but if you follow my circuit around, I'm actually going to be reading resistance through the power supply as well, and it's going to give me an inaccurate measurement. So when I'm measuring the resistance across a component, I have to isolate that component. So to do that, I don't have to remove both sides. I just need to remove one side to remove that alternate path for the resistance measurement. So now, if I touch across this lamp, if I just go from here to here, the only path for this resistance read is through the lamp. So that tells me the reading that I get will be just the resistance of the lamp, which is what I'm after. So if I read the resistance across the lamp, you'll see that I'm reading roughly 3.2 ohms. So that's a relatively low resistance value. So let's hook this back up, and let's go back to our selector switch just for a minute. Our selector switch is either an open circuit or a short circuit, or a closed circuit. So if I open this component, so now if I read across from point A to point B, let's put that on there, you'll see that it shows that that's a out of range arrangement. So if I keep turning this up into higher ranges, I can go ahead and go all the way up to the max. It should show that there is no current or no resistance across that switch. So if I close the switch, now you should see that I have next to zero resistance, and you can see when I open and close the switch, that resistance will change. It goes from open to a close. And that's why we were seeing the voltage readings that we were seeing when the switch was open. There was infinite resistance there, so it was dropping all the voltage for that circuit. And then when I close the switch, there's essentially 0 ohms there, and that explains why I was reading 0 volts across here with the switch closed. So now we've read the resistance of our switch, we've read the resistance of our lamp, and if we go back to what it read, the lamp was just over 3 ohms. So if we do some simple Ohm's law, what we learned in lesson 4, if we take our 12.2 volts and divide it by our 3.1 ohms resistance across the lamp, that tells us we should have roughly 3.9 amps in this circuit. So we have a pretty good idea what the current is going to be in this circuit. So the first thing I need to do is set my meter up to read DC current, and I'm going to spin it around here. I can either set it on the full 10 amp range, or I have a milliamp range, which is a little more precise. But if you remember from the lesson on using digital multimeters, that when you're taking a current read, you always want to start high and work your way down to keep from damaging your meter, because like I said, we've determined we're going to have about 3 or 4 amps here. If we try to measure that in the milliamp range, we could damage the meter or blow an internal fuse, and you have to go and replace the fuse and hopefully not hurt your meter. But since we know we're going to be above the 200 milliamp range, we're going to go ahead and set it up for the 10 amps. So I have to move my probe over here to the 10 amp jack on the meter, and to make a current read, the current actually has to be flowing through the meter. So to do that, I need to open remove a conductor somewhere in the circuit. And in a series circuit, it doesn't matter which one I move, because everything in here, the current's going to be the same through at every point throughout the circuit. So I just chose to remove the conductor between my selector switch and my lamp to measure the current. So what I'm going to do is turn the power back on to the power supply, and then touch my meter to these 2 points, and essentially taking place of the conductor. And now the current will be flowing through my red conductor into the meter, then back out of my black conductor and through the rest of the circuit. So that's how we set it up. Just remember, when you're reading current with a digital multimeter, you have to actually break the circuit and then insert the meter, and the meter becomes part of the circuit and replaces the conductor. So I'm going to turn my switch on. You can see my lamp's not lit because I don't have a complete circuit. And when I touch my meter here, I'll be completing the circuit, and my current will be displayed on my readout here. So I touch it here, you see my lamp's lit, so the current's flowing, and we are showing basically 477 milliamps, or 0.477 amps. If you think back to what we just determined, if our voltage was 12.2 volts and a resistance of the lamp, we should have had close to 4 amps. So why are we only having a little less than a half amp at 477 milliamps? One thing you'll learn later in this AIT program is that the resistance of a conductor will change with heat or with temperature. So the hotter you get a conductor, the more resistance that conductor will have. And the same thing happens with wire and components. So what's happening is, when we illuminate the lamp, that filament gets extremely hot enough to glow, so that's how it gives off the lamp. But also the temperature goes up in an immense amount. So as the temperature goes up, so does the resistance. And that will drop our current, as what Ohm's law tells us. If the voltage stays the same and the resistance goes up, our current will drop, which is what's happened here. So with this new information, so we know that when the lamp is cold, that the resistance of that lamp is 3.1 ohms. But now that it's heated, when it heats up, when it illuminates, that resistance changes and gives us a current of 4.77. So if we use Ohm's law, we take our 12.2 volts, divide it by our 477.75 milliamps. That gives me a resistance of a little over 25 ohms, 25.5 ohms, while the filament's burning. So the resistance goes up almost 22 ohms just from being from room temperature to hot, and that's what we're seeing. So to review, to do a voltage read, we set the meter up for voltage, make sure we're in the correct AC or DC, have the probe in the correct port or the correct jack on the meter, and then when you take the read, you just basically touch across 2 points, and the meter will tell you the difference in potential between those 2 points. And again, it's not telling you if voltage is present, it's just telling you if there's a difference in potential between the 2 points you're testing. Resistance readings, we have to isolate the component we're wanting to read, so we have to take at least one side of one lead off of that component. So when we read the resistance across this component, we're not reading back through the power supply and other parts of the circuit. And then for a current read, we have to remove a conductor and replace that conductor with a meter set up to read current. So that's what we have. If you have any questions, please post them to the discussion boards, or my contact information is listed where I can be contacted. Thank you.